Good morning. My name is Lalit, and I'm presenting here a fine-grained approach to develop domain-specific search engine. And my mentor is Professor Raghu Reddy. The outline of the talk is we talk about the motivation, what are the research questions that we are dealing with, and what are the contributions that we are doing in URL extraction, ontology enrichment, credibility assessment, and implementation in terms of a siren. First, let's understand the generic search engines, whether it is in the research or whether it is in the production. The large-scale generic search engines are all notorious or probably have concerns in terms of relevance, bias, content filtering, click spam, and many other issues. Now, if you look at domain-specific search engines, other than dealing with these issues, they also are known to bring some specificity. What I mean to say by specificity is, if you look at Wells Fargo as a keyword on a generic search engine, it would talk about generically about Wells Fargo, whereas a Yahoo Finance, a domain-specific search engine, would talk about its stock price and some of the things that are happening in the finance world because Wells Fargo is a bank. Right now, when we did a study to understand what these research that is happening on domain-specific search engines, what it came to know is efficient crawlers are required to reduce crawl time. Probably this is certainly required as these domain-specific search engines are trying to cull out or prune the information that is generically available and make it relevant for the domain. Improve extract quality to represent domain and optimize compute resources because of the additional compute that it has to do in terms of removing non-domain content. Machine learning and natural language processing are certainly being used to enrich knowledge graphs, ontologies, and other semantic forms to improve extract and retrieval quality in search engines. Credibility, reputation, and authority are researched to provide quality search results. Search quality assessments and validations leveraged crowdsourcing, ground truth or golden sets data sets in a domain aid evaluation. These are some of the findings that we found when we did a survey on what's happening, a literature survey on what's happening on domain specific search engine research. Now let's understand what is there as the search engine components. You typically have a focus crawler, which is trying to get some seed URLs that are specific to the domain. Then that seed URLs are given to this focus crawler, which is trying to extract content that represents the domain, and accordingly that extracted domain is used to build a knowledge base, which could be in the form of a knowledge graph or an ontology, and that is indexed for ranking and then showing results with that domain specificity. Now, what are the questions that we are dealing in this work? What are subdomains and how to systematically identify subdomains in a domain? What we want to also get is, are there enough URLs that represent subdomains of a domain? Because you don't want to generally go build a domain specific search engine when there are not enough representations that is happening for a subdomain of that domain. What approach provides efficient crawling while ensuring search quality? What are current methods in ontology enrichment and how to enrich a seed ontology with multi-words and instances from a domain-specific content while maintaining context? What are existing approaches and their gaps to assess search results quality? What factors influence web page credibility and how it can be used for ranking with flexibility for user intervention? Now let's deal with the first one. I'm just trying to make sure that we understand this is the scope of this work. What we want to answer is selection of seed URL today is manual in a lot of cases and requires thorough investigation to determine seed URL relevant. Additional processing is required to remove uncrawled or unrelated crawled content because you don't want, you have a domain specific search engine, you don't want unnecessary content which is not specific to the domain. Also, what we want to look in this work is subdomains of a domain are represented. Not only that, only part of subdomains we don't want to have that problem. We also don't want to have a problem where subdomains are all present, but the content for those subdomains is less. We want to ensure that all these problems are worked out in this work. To do this, we actually came up with an approach where we are extracting URLs from two repositories, Wiki and the Twitter, so that we reduce the a bias in our approach. And then we have used um, a systematic approach to identify subdomains of a domain, and then went about crawling and then finding the subdomain representation and the seed URLs relevance for that subdomain. Now, to do this, we actually extended a heuristic algorithm called ABC algorithm, artificial bee colony. What it helps is in terms of uh, doing a continuous extraction of URLs at the same time, doing it in an optimized way, figuring out the routing part, and meta heuristic algorithm, especially ABC, is known for exploration and exploitation capability. Now, this approach is when we compared with existing open source industry scale crawlers like Apache Nutch or Storm Crawler, we found with our extended approach, we suddenly consume less CPU and even RAM as compared to the large scale deployments. Now, we also proposed a metric on seed relevance and domain diversity. The seed relevance validates whether whatever the seed URLs that we extracted are actually relevant for the subdomains, and are they rich enough in terms of getting content with that subdomain specific URLs. Secondly, we proposed a domain diversity, which is more of an entropy based metric to see whether we are extracting URLs and we are trying to say that that represents subdomains of a domain, and how do we validate that there is sufficient diversity that is available in that subdomain. This approach we implemented on enterprise architecture specific to information security. Um, and then these are some of the results. What you could see is for the period that we ran, we were able to extract about 400,000 URLs and about 34,000 seed URLs with good representation about all the subdomains that are specific to the enterprise architecture. We also see the diversity metric. This is based on the meta heuristic data. You see that there is a fair representation of the diversity of the subdomains. We compared with other approaches like topic modeling, clustering, and some of the recent work. What we realized is suddenly our approach performed better both in terms of identifying more URLs as well as identifying the subdomains. Second, our work is what are current methods in ontology enrichment and how to enrich a seed ontology with multiwords and instances from domain specific web content while maintaining context. So we extracted the content. Now we want to enrich the knowledge base. That's where this scope is coming to the picture. This is the part that we are dealing in terms of the work. To do this, what we did is we had our data set, then we systematically identified a seed ontology. We extracted the to train the model. We are proposing a deep learning method in terms of training and extracting the concepts relationships to enrich an ontology. For that, other than the corpus that we had, which is more from a testing perspective, we extracted corpus from Wikipedia. We also extracted some test corpus that from the extracted URLs, and then we used to extract the concepts and the related terms to prepare a training data set, which is used to train an ontology enricher. Now, to train the model, we use the bidirectional LSTM, which not only factors the sequencing and has the forget cells, memory cells, but also handles better in terms of the multi-words and also the context being available in form of a sentence rather than a single word, which is typically what the way the word-to-vec and similar models are doing. Now, we with this approach, we actually are able to enrich the ontology, and we also implemented universal sentence encoder so that the context similarity is better. This is an example of that implementation. You could see the ontology term is a real-time adaptive security, which is a multi-word, and it goes about identifying in a bidirectional LSTM model with universal sentence encoder for similarity the relevant concept. We performed this against the DBpedia dataset, removing some ontology concepts from the seed ontology and also some web page that we got from the extracted content on the random text. In all, we could see that certainly we performed close to about 80%. And when we did a random, we also see that, yeah, we have a precision about 84%. We try to do in terms of the hyponyms, concepts, and instances seems to be pretty decent in terms of the capability to extract concepts and relationships. Now we had the extracted content, we have uh, the the ontology enriched. Now we want to assess whether the content that we extracted is credible enough either to show the results or even to enrich the ontology. For that, this is the part that we are trying to deal with. For that, what we did is first we want to see whether there is an aspect of genre, right? What we mean to say genre is a similar content which is written in an article or a shopping website or a personal web page or a professional website or an organizational website all means different, right? And that could have a view in terms of the credibility of the content. To validate whether actually credibility differs from genres of a web page, we actually did a crowdsourcing, and we realized that yeah, crowds actually came back and said yeah, it does make sense, it does differ. The credibility does differ based on the genre of a web page. Um, we proposed an approach which factors how to identify these genres. The genres are in terms of the web page elements that are visibly available, obvious on the surface of a web page. Could be the language, the content, or the off page, which could be the in links, the response load time, and so on and so forth. Now, with this approach, we actually went about trying to identify the genre and also accordingly propose a credibility score to evaluate. So we used a supervised learning model to train the models to identify genre. And we see, yeah, for a few of the genres that we established in terms of article genre, the supervised learning model certainly performed better. um, to give the flexibility in terms of user interface, trying to assess the credibility, we also provided a flexibility for users to go change the weightages of these features based on the genre as well as the category, whether it is a surface or whether it is content or an off page. We proposed a metric to or measure to calculate these independent variables for a genre credibility score of the web page. What we did is when we compared this with a page ranking algorithm like Alexa and our credibility score, you could see a web of trust kind of, which is more of an individual or crowd-based assessment of a web page. We correlated more with web of trust kind of a scenario rather than a page ranking algorithm. This kind of establishes that our approach is kind of closer to the way that an individual would like to validate a web page credibility. Now, to implement all this, what we proposed as an approach, we actually demonstrated on a search engine, a domain-specific search engine that is related to information security. And this is funded by the Department of Science and Technology, Government of India. Now, why information security? Increasing usage of IT, certainly we need to protect those IT assets, and there are opportunities to access vulnerabilities, threats, advisories that is available on the open thread, which is otherwise very expensive, and also it helps various government initiatives, whether it is MyGov, which is trying to create awareness on cyber attacks, or certain or NCIPC or ISACs, which are sharing amongst the sectors for protection. These are some of the use cases for the citizens, government organizations, security service providers, which are actually providing security solutions, and academicians and researchers like us. To do this, what we have proposed as an approach, we actually developed a demonstration. It's also available. I'll share it later in the slides, but it is also available. Otherwise, we would have been challenged in terms of buying these expensive threat intelligence from service providers. These are the primary contributions from our work. Um, and this is where you could access the website, and this is the source code that's available for you to consume. And if you have any other inputs, please share the feedback on this jot form. If you have more questions, you could certainly send across as an email to me. Thank you so much. Have a good day.